Astronomers do something called a distance ladder to determine how far away super-distanced objects are. There are 4 steps to this ladder: radar, parallax, standard candles, and Hubble law. These steps are in order from finding close distances to the farthest distant stars in the universe. The first step on the distance ladder is radar. This is an acronym for radio, detection, and ranging, where a radio pulse is reflected off of various objects but is only capable of measuring distances within our own solar system. How this works is a radio pulse is beamed from a radio telescope to, let's say, a planet in our solar system. Then the reflected pulse is timed, and since the radio waves are traveling at the speed of light, we can determine the distance of the planet. The second step of the distance ladder is parallax. This star is observed in, say, December, and then in June, the direction of the star in respect to the sun is measured in both cases, which is this angle. Then, knowing these angles and the diameter of the Earth around the sun, we would be able to tell this distance to the star. But, as we look at farther and farther stars, the angles measured come closer to 90 degrees. For stars more than a couple hundred light years from Earth, we would not be able to distinguish the angles from right angles, and the method fails. The next step is standard candles. A standard candle is an object whose luminosity can be determined without measuring its distance. We can determine a star's distance if we know its luminosity and can measure its apparent brightness. The formula to finding distance is the square root of luminosity over brightness. An example of a standard candle would be using a Cepheid variable star. In 1912, American astronomer Henriette Levy discovered that the period of the Cepheid variables depends on the star's mean absolute magnitude, or the more luminous the star, the longer the period. Here in this graph, this shows the relationship between luminosity and period, and you would find the luminosity here and the period in days. Bring the period of days over here to find the apparent brightness. You would use these numbers and plug it into this formula to find the distance using standard candles. The final step on the distance ladder is Hubble law. Hubble noticed that almost all galaxies are redshifted, meaning they're moving away from our galaxy. This means that our universe has a constant expansion rate which appears to be the same everywhere in space. The formula for the Hubble constant is h equals v over d, where v is the observed velocity of the galaxy away from us, h is the Hubble constant, and d is the distance to the galaxy from Earth. This creates the Hubble diagram, which determines the Hubble constant. Here you have the distance in megaparsecs, and here's the velocity. And how to determine the Hubble constant, which they have 68, is you would go 10 megaparsecs. You would find this this galaxy, you go over, and it's in between 500 and 1,000, so it's about 700. You would take this number divided by 10, that's around 70, and that's how they got their 68 for the Hubble constant. And this is Hubble law. Here's an overview of the distance ladder. You have radar to find distances in our solar system. Parallax uses math equations to calculate distances as far as a few hundred light years. Standard candles use Cepheid variable stars to find far distances. And lastly, Hubble law uses the velocity of redshift with distance to find the Hubble constant. With these 4 major steps to the distance ladder, astronomers now know the distances of stars from almost anywhere in the universe.